Hello, in this lecture we'll find out the length of line segment X. In the drawing we have a regular hexagon. A regular hexagon is a closed polygon with 6 equal sides and 6 equal angles. And side AB equals to 2 units, therefore all the other sides that are equal to each other are also equal to 2 units. So here side CB equals to 2 units, side DC is also equal to 2 units, side ED equals to 2 units, side EF equals to 2 units, side FA equals to 2 units, and all the 6 interior angles are equal to each other. That is to say, those those 6 interior angles are also equal to each other. And we also know that line segment PB equals to 3 units. Our mission is to find out the length of side AP that is equal to X. To find out the value of X. So first of all, we find out what is the sum of the angles in any regular hexagon. So I will draw a regular hexagon. That could be any regular hexagon, and we'll find out what is the sum of the angles in any regular hexagon. So we have here hexagon ABCDEF. This is regular hexagon. ABCDEF. In order to find out the sum of those 6 interior angles, we will join points A and B together by a straight line. By joining points B and E, which are actually created here, 2 quadrilaterals, quadrilateral ABFE and quadrilateral BCED. And we know that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the sum of the angles in quadrilateral ABFE is equal to 360 degrees. And the sum of the angles in quadrilateral BCDE is also equal to 360 degrees. And because of the fact that this regular hexagon consists exactly those 2 quadrilaterals, it means that the sum of the angles in those 2 quadrilaterals will be equal to the sum of the angles in this regular hexagon. And the sum of the angles on those 2 quadrilaterals is 360 degrees plus 360 degrees, that is 720 degrees. And therefore, the sum of the angles in this regular hexagon it is equal to 720 degrees. And because of the fact that this regular hexagon has 6 interior angles that are equal to each other, it means that the total sum of those 6 equal angles, that is 720 degrees, over the number of the interior angles, that is 6, will give us the size of one interior angle. So 706 is 120 degrees. So we found out that the size of one interior angle of this regular hexagon is equal to 120 degrees. So we can write down that all those 6 interior angles are equal to 120 degrees in their sizes. This angle equals to 120 degrees. This angle equals to 120 degrees. This angle equals to 120 degrees in its size. this angle equals to 120 degrees, this angle equals to 120 degrees, and this angle equals to 120 degrees in its size. We will extend side DC by a straight line. We will define this point as point L. DC is one side out of the 6 sides of this regular hexagon, therefore it is absolutely a straight line. And when we extended the straight line DC by a straight line, the result must be a straight line. So therefore DL is a straight line. So I write it down. DL, line segment DL is a straight line. DL is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the left side of the straight line DL at point C, here the sum of the angles must be equal to 180 degrees according to rule number 1. So which angles we have at this side of DL at point C? We have this angle that is equal to 130 degrees plus the missing angle, that is actually angle BC. And in total, they must be equal to 180 degrees according to rule number 1. So I write it down, 120 degrees plus the missing angle, that is actually angle BCL. In total, they must be equal to 180 degrees according to rule number 1. So here we subtract 120 degrees from this equation, and we get that the missing angle, angle BCL, equals to 180 degrees minus 120 degrees, it is 60 degrees. Okay, so we actually found out that the missing angle, angle BCL, equals to 60 degrees in its size. In the next step, from point B, we will draw perpendicular on DL. Again, from point B, we will draw perpendicular on DL. So actually, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point B and DL as M. By doing this construction, we created here the right triangle, triangle CMB. So I copy triangle CMB in a new page and we'll analyze it. So this is triangle CMB. This is triangle CMB that I copied from the original drawing. Angle MCB equals to 60 degrees according to rule number 1. Angle CMB equals to 90 degrees according to our construction. So in this triangle, triangle CMB, we know that cosine 60 degrees equals to CM over CB. Repeat again, triangle CMB, the right triangle CMB, cosine 60 degrees equals to CM over CB. Cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2. And this is equal to CM. CM is the missing side, so we leave it as it is, over CB. CB equals to 2 units, therefore we substitute CB by 2. In conclusion, we found out that CM over 2 equals to 1/2. Here we will multiply this equation by 2 and we get that CM equals to 1 unit. Here cm equals to 1 unit. Here also we can write down in the original drawing that cm equals to 1 unit. Likewise, we continue to focus on the right triangle CMB. In this right triangle, sine of 60 degrees equals to MB over the hypotenuse CB. Here sine of 60 degrees equals to MB over CB. Sine of 60 degrees equals to the square root of 3 over 2, so we substitute sine of 60 degrees by square root of 3 over 2, and it is equal to MB. MB is the missing side, so we leave it as it is, over CB. CB equals to 2, therefore we substitute CB by 2. In conclusion, we found out that square root of 3 over 2 equals to MB over 2. Here we multiply this equation by 2, and we find out that MB equals to the square root of 3 units. Here MB equals to the square root of 3 units, and we can write down in the original drawing that MB equals to the square root of 3 units. In the next step, we focus on the right triangle PMB. On this right triangle PMB, side PM equals to PC plus CM. Again, PM equals to PC plus CM. PM is unknown, so we'll define PC is unknown. Here PC is unknown, so we'll define PC as A. The length of PC is A according to our definition. CM equals to 1. So in total, PM equals to PC plus CM. PC is A, CM is 1, so it is A plus 1. Side PM equals to A plus 1. BM equals to the square root of 3 units, and the hypotenuse PB equals to 3 units according to what is given us in the question. So we copy the right triangle PMB in a new page, and we will implement here the Pythagoras theorem in order to find out the value of A. So this is the right triangle PMB that I copied from the original drawing. Side PM equals to A plus 1, BM equals to the square root of 3 units, and the hypotenuse PB equals to 3 units according to what is given us in the question. So here, by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is PB, therefore the square of the hypotenuse is PB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM squared plus BM squared. So according to the Pythagoras theorem, PB squared equals to PM squared plus BM squared. PB is 3, so PB squared is 3 squared, that is 9, and it is equal to PM squared. PM is A plus 1, therefore PM squared is A plus 1 squared plus BM squared. BM is square root of 3, therefore BM squared is square root of 3 squared. So in conclusion, we found out that 9 equals to A plus 1 squared, and square root of 3 squared is 3, so 9 equals to A plus 1 squared plus 3. Here we subtract 3 from this equation, and we get that 9 minus 3 is 6, so 6 equals to A plus 1 squared. Here we'll take out of this equation, and we get that the square root of 6 equals to A plus 1. So here we subtract 1 from this equation, and we get that A equals to the square root of 6 minus 1 units. Okay, so we can write down in the original drawing that A equals to the square root of 6, the square root of 6 minus 1 units. Okay. In the next step, we'll join points A and C together by a straight line. By joining points A and C, we created the right triangle ABC. This is triangle ABC. Angle ABC equals to 120 degrees because it is one out of the 6 interior angles of the regular hexagon ABCDEF. Okay. So we know that side AB equals to side BC equals to 2 units. They are both the sides of this regular hexagon, and all the sides of this regular hexagon are equal to 2 units in their lengths. So we will implement in this triangle ABC the law of cosines in order to find out the length of side AC. So what is the law of cosines? The law of cosines is true in any triangle. So if we have triangle ABC, that could be any triangle. This is triangle ABC. We know that the length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length, and the angle between side AB and side AC is theta. Then according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. I'll repeat again. This triangle ABC, that could be any triangle. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. We will implement the law of cosines in our triangle ABC. So I'll copy triangle ABC in a new page and we'll implement on it the law of cosines. So actually this is triangle ABC that I copied from the original drawing. Angle ABC equals to 120 degrees and AB equals to BC equals to 2 units. According to the law of cosines, we get that AC squared equals to AB squared plus BC squared minus 2 times AB times BC times cosine 120 degrees. So this equation is the implementation of the law of cosines in our triangle ABC. AC squared equals to AB squared plus BC squared minus 2 times AB times BC times cosine 120 degrees. So AC squared equals to AB squared. AB is 2, so AB squared is 2 squared, that is 4, plus BC squared. BC is 2, so BC squared is 2 squared, that is 4, minus 2 times AB is 2, BC is 2, and cosine 120 degrees is equal to minus 1 half. So we substitute cosine 120 degrees by minus 1 half. So this expression, in this expression we have minus times minus, that is plus. So this expression will be a positive number. So 2 times 2 is 4, and 2 over 2 is 1. So those 2 will get cancelled and we left only with 4. So actually 4 plus 4 plus 4 equals to AC squared. So AC squared equals to 4 plus 4 plus 4, that is 12. Here we'll substitute 12 by 4 times 3, so AC squared equals to 4 times 3. Here we take a root out of this equation and we get that AC equals to the square root of 4 times 3. We take 4 out of the root and we get that AC equals to the square root of 4 is 2, so and inside the root we left only 3. So we found out that AC equals to 2 times square root of 3. Here AC equals to 2 times square root of 3 units. We continue to focus on triangle ABC and we find out the sizes of those two angles. Because of the fact that side AB equals to side BC equals to 2 units, so we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides we have those two angles that also must be equal to each other. So if this angle is x, then this angle must be equal to x because they are equal to each other. So, and we also know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ABC. So which angles we have in triangle ABC? We have x plus 120 degrees. In total they must be equal to 180 degrees. We subtract x plus x is 2x, so 2x plus 120 degrees equals to 180 degrees. We will subtract 120 degrees from this equation and we get that 2x equals to 180 degrees minus 120 degrees, it is 60 degrees. So 2x equals to 60 degrees. We divide this equation by 2 and we get that x equals to 60 degrees over 2 is 30 degrees. So this angle x equals to 30 degrees and this angle x it is also equal to 30 degrees. So this angle x it is actually angle ACB. So we found out that angle ACB equals to 30 degrees, so we can write down in the original drawing that this angle ACB equals to 30 degrees. Okay, angle ACB equals to 30 degrees. The big angle PCB equals to 120 degrees. The small angle ACB equals to 30 degrees, therefore the missing angle PCA will be equal to the big angle, that is angle PCB, minus the small angle, that is angle ACB. So I will copy again the three angles. We have the big angle PCB. This angle is angle PCB that is equal to 120 degrees. We have the small angle ACB that is equal to 30 degrees. So this angle ACB equals to 30 degrees. And therefore the missing angle PCA will be equal to the big angle PCB minus the small angle that is ACB. Repeat again, the missing angle PCA, this angle PCA will be equal to the big angle that is angle PCB minus the small angle that is angle ACB. So the missing angle PCA will be equal to the big angle PCB that is equal to 120 degrees minus the small angle ACB that is equal to 30 degrees. So we found out that the missing angle PCA equals to 120 degrees minus 30 degrees, it is 90 degrees. So actually the missing angle PCA, it is a right angle. Okay. the missing angle PCA equals to 90 degrees, therefore it is a right angle. And because of the fact that angle PCA it is a right angle, therefore triangle PCA is a right triangle. Okay? Here, triangle PCA is a right triangle. Repeat again, the green triangle PCA is a right triangle. So I'll copy the right triangle PCA in an equation. We'll implement the Pythagoras theorem in this right green triangle PCA. Okay. This angle equals to 90 degrees. This is a right angle. So actually this is the right triangle PCA that I copied from the original drawing. Side PC equals to A equals to the square root of 6 minus 1 units. Side AC equals to 2 times square root of 3 units. And AP equals to X, that is the line segment that we are looking for. This is the missing angle that is equal to 90 degrees. Okay, the missing angle that we found earlier. So we will implement the Pythagoras theorem in this right triangle PCA. So here by PT is a variation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. The hypotenuse in this right triangle APC is AP, therefore the square of the hypotenuse is AP squared, and it must be equal to the sum of the sides of the perpendiculars. That is to say, it must be equal to PC squared plus AC squared. So actually AP equals to X, therefore AP squared is X squared, and it must be equal to PC squared. PC is square root of 6, therefore square root of 6 minus 1, therefore PC squared is square root of 6 minus 1 squared plus AC squared. AC equals to 2 times square root of 3, therefore AC squared equals to 2 times square root of 3 squared. So we found out that X squared equals to the square root of 6 minus 1 squared plus 2 times square root of 3 squared. 2 times square root of 3 squared equals to 2 squared, that is 4, times square root of 3 squared, that is 3. 4 times 3 is 12. In conclusion, we found out that X squared equals to the square root of 6 minus 1 squared plus 12. We will find out the value of this expression, square root of 6 minus 1 squared, according to the algebraic identity that states that A minus B squared equals to A squared plus B squared minus 2 times A times B. In our specific expression, square root of 6 minus 1 squared, A equals to the square root of 6 and B equals to 1. And therefore, according to this algebraic identity, square root of 6 minus 1 squared will be equal to A squared. A is square root of 6, therefore A is square root of 6, therefore A squared is square root of 6 squared, that is 6, plus B squared. B is 1, so B squared is 1 squared, that is 1. Minus 2 times minus 2 times A is square root of 6, and B is 1. So in conclusion, we found out that square root of 6 minus 1 square according to this algebraic identity equals to 6 plus 1, that is 7, minus 2 times square root of 6. Again, square root of 6 minus 1 square equals to 7 minus 2 times square root of 6. Therefore, we can substitute square root of 6 minus 1 square in this equation by 7 minus 2 times square root of 6. So we'll do it now, and we'll get that x squared equals to square root of 6 minus 1 square equals to 7 minus 2 times square root of 6. And we have here also plus 12. In conclusion, I found out that x squared equals to 7 plus 12 is 19. It is 19 minus 2 times square root of 6. Here we take a root out of this equation, and we get that x equals to the square root of 19 minus 2 times square root of 6. Or in terms of numbers, x equals to 3.755 units. Repeat again. Line segment AP is equal to x equals to either the square root of 19 minus 2 times square root of 6 square, or in terms of numbers, x equals to 3.755 units. Okay, that is the answer to our question. In the next step, I will summarize the lecture. In the drawing, we have a regular hexagon. A regular hexagon is a closed polygon with 6 equal sides and 6 equal interior angles. Okay, we know that one side of this regular hexagon is equal to 2 units, AB equals to 2, therefore all the other sides must be also equal to 2 units. And repeat again that all the 6 interior angles of this regular hexagon must be also equal to each other. In addition, we know that line segment PB equals to 4 units, and our mission is to find out the length of line segment PA that is equal to x. We have to find out the value of x. Okay, so first of all, we found out the sum of the angles in any regular hexagon. So I draw here a regular hexagon A, B, C, D, E, F, and found out the sum of the angles in this regular, the sum of the interior angles, those 6 interior angles in this regular hexagon A, B, C, D, E, F, that could be any regular hexagon. In order to find out the sum of the angles in this regular hexagon, we join points B and E. By joining points B and E, we get that here 2 quadrilaterals, quadrilateral ABFE and quadrilateral BCED. We know that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the sum of the angles in quadrilateral ABFE equals to 360 degrees, and the sum of the angles in quadrilateral BCED is also equal to 360 degrees. And therefore, the sum of the angles on both quadrilaterals must be equal to the sum of the angles in this regular hexagon. Why? Because of the fact that this regular hexagon consists of those 2 quadrilaterals, exactly the sum of those 2 quadrilaterals. It is actually give us this regular hexagon. So the sum of the angles in those 2 quadrilaterals is 360 degrees plus 360 degrees, that is 720 degrees. So the sum of the angles in our regular hexagon, it is equal to 720 degrees, and we know that any regular hexagon has 6 interior angles that are equal to each other. So if we define the sum of the total angles by the number of the interior angles, the sum of the total interior angles over the number of the interior angles, it will give us the size of one interior angle. So it is the sum of those total internal angles, it is equal to 720 degrees over the number of the internal angles, that is 6. So 720 degrees over 6 will give us the size of one internal angle that is actually 120 degrees. So we found out that in any regular hexagon, the size of one internal angle will be equal to 120 degrees. And especially in our regular hexagon, all the internal angles, all the 6 internal angles are equal to 120 degrees. In the next step, we extended side DC by a straight line. DC is a straight line, and when we extend the straight line DC by a straight line, the result DL must be a straight line. So here DL is a straight line, and we have rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the left side of the straight line DL at point C, the sum of the angles at this side of DL at point C must be equal to 180 degrees according to rule number 1. So which angles we have at this side of DL at point C? We have this angle that is equal to 120 degrees plus the missing angle, angle BCL. In total, they must be equal to 180 degrees according to rule number 1. I repeat again. At the left side of the straight line DL at point C, we have one angle that is equal to 120 degrees plus the missing angle, angle BCL. In total, they must be equal to 180 degrees according to rule number 1. So here we subtracted 120 degrees from this equation, and we found out that the missing angle, angle BCL equals to 180 degrees minus 120 degrees, it is equal to 60 degrees. So here the missing angle, angle BCL equals to 60 degrees. Then from point B, we draw perpendicular on DL. Again, from point B, we draw perpendicular on DL. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DL as M. By doing this construction, we created the right triangle, triangle CMB. So I copied the right triangle CMB in the new page and we analyzed it. This is the right triangle CMB that I copied from the original drawing. This angle equals to 60 degrees according to rule number 1, and this angle equals to 90 degrees according to our construction. In this triangle, triangle CMB, we know that cosine 60 degrees equals to CM over CB. Again, cosine 60 degrees equals to CM over CB. Cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2. And it is equal to CM. CM is the missing side, so we leave it as it is, over CB. CB equals to 2 units, therefore we substitute CB by 2. So we found out that 1/2 equals to CM over 2. We multiplied this equation by 2, and we found out that CM equals to 1 unit. CM equals to 1 unit, and here again CM equals to 1 unit. We continue to focus on the right triangle CMB. In the right triangle CMB, sine of 60 degrees equals to MB over CB. Sine of 60 degrees equals to MB over CB. Sine of 60 degrees is square root of 3 over 2, so we substitute sine of 60 degrees by square root of 3 over 2, and it is equal to MB. MB is the missing side, so we leave it as it is, over CB. CB is 2, so we substitute CB by 2. Here we multiply this equation by 2, and we found out that MB equals to the square root of 3 units. MB equals to the square root of 3 units, and here again, MB equals to the square root of 3 units. Okay? Then we focus on the right triangle, triangle PMB. In the right triangle PMB, PM equals to PC plus CM. PC is unknown, so we define PC as A, and CM is 1. So PM equals to PC plus CM. PC is A, CM is 1. So in total, side PM equals to A plus 1. Side BM equals to the square root of 3 units, and PB equals to 3 units according to what is given as the equation. So I copied the right triangle PMB in this new page and implemented here the Pythagoras theorem. Okay? According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is PB, and therefore the square of the hypotenuse is PB squared. It must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM squared plus BM squared. So PB equals to 3, therefore PB squared is 3 squared, that is 9. PM equals to A plus 1, therefore PM squared equals to A plus 1 squared plus BM squared. bm equals to the square root of 3, therefore bm square equals to the square root of 3 square. So 9 equals to a plus 1 square plus square root of 3 square. Square root of 3 square is 3. So in conclusion, we found out that 9 equals to a plus 1 square plus 3. Here we subtracted 3 from this equation. We found out that 9 minus 3 is 6. So 6 equals to a plus 1 square. Here we took out of this equation. We found out that square root of 6 equals to a plus 1. Here we subtracted 1 from this equation. We found out that a equals to the square root of 6 minus 1 units. So here we can write down the original drawing that a equals to the square root of 6 minus 1 units. Okay, in the next step, join points A and C together by a straight line. By joining points A and C, we can get here triangle ABC. This is triangle ABC. This angle ABC, it is the interior angle of the regular hexagon that is equal to 120 degrees. Side AB equals to side BC. They are both the sides of the regular hexagon, therefore they are equal to 2 units. Then we implemented the Pythagoras theorem on this. We implemented the law of cosines in this triangle ABC. What is the law of cosines? The law of cosines is true in any triangle. So we have a triangle ABC that could be any triangle. And the length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length. According to the law of cosines, we will get that C square equals to A square plus B square minus 2 times A times B times cosine theta. We can actually implement the law of cosines in our triangle ABC. So I copy triangle ABC in this page, and we implemented the law of cosines. Side AB equals to side BC equals to 2 units, and this is the interior angle of the regular hexagon ABCDEF, therefore it is equal to 120 degrees. So we implemented the law of cosines in order to find out the length of side AC. According to the law of cosines, we get that AC square equals to AB square plus BC square minus 2 times AB times BC times cosine 120 degrees. This equation is the implementation of the law of cosines in our triangle ABC. AC square equals to AB square. AB is 2, so AB square is 2 squared, that is 4, plus BC square. BC is 2, so BC square is 2 squared, that is 4. Minus 2 times AB is 2, and BC is 2 times cosine 120 degrees. Cosine 120 degrees, it is minus 1 half, so we substitute cosine 120 degrees by minus 1 half. In this expression, we have minus times minus, that is plus. So this expression in total will be a positive number. So we have here 2 times 2, that is 4, and 2 over 2 is 1. So those two will get cancelled, and we left only with 4. In conclusion, we found out that AC square equals to 4 plus 4 plus 4, that is 12. AC square equals to 12. We substitute 12 by 4 times 3, so AC square equals to 4 times 3. Here we took out of this equation, we found out that AC equals to the square root of 3 times 4. The square root of 4 is 2, so we took 4 out of the root, and in conclusion, we found out that AC equals to 2 times square root of 3 units. So here we can write down that AC equals to 2 times square root of 3 units. We continue to focus on the right triangle ABC in order to find out the sizes of those two angles. We know that side AB equals to side BC, and we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, there must be those two angles that are equal to each other. Okay, so those two angles are equal to each other because of the fact that they are located in front of equal sides. So if this angle is x, then this angle must be also equal to x. And we know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ABC. So which angles we have in triangle ABC? We have this angle that is x, this angle equals to x, and this angle that is equal to 120 degrees. So x plus 120 degrees must be equal to 180 degrees. X plus x is 2x. So 2x plus 120 degrees, it is equal to 180 degrees. We subtracted 120 degrees from this equation, and we found out that 2x equals to 180 degrees minus 120 degrees equals to 60 degrees. So 2x equals to 60 degrees. We divided this equation by 2, and we got that x equals to 60 over 2, that is 30 degrees. So this angle x equals to 30 degrees, and this angle x equals to 30 degrees. That is to say, this angle, this is actually angle ACB equals to 30 degrees. So we can write down in the original drawing that this angle ACB equals to 30 degrees. we know that the big angle PCB equals to 120 degrees, the small angle ACB equals to 30 degrees, therefore the missing angle, that is actually angle PCA, will be equal to the big angle minus the small angle. So I copy the three angles here. The big angle PCB equals to 120 degrees. The small angle ACB equals to 30 degrees. Therefore, the missing angle PCA will be equal to the big angle PCB minus the small angle, that is ACB. So the missing angle PCA equals to the big angle PCB minus the small angle ACB. So the missing angle PCA, this is angle PCA, it is equal to the big angle PCB, that is equal to 120 degrees, minus the small angle ACB, that is equal to 30 degrees. So in conclusion, we found out that the missing angle PCA equals to 120 degrees minus 30 degrees. 120 degrees minus 30 degrees, it is 90 degrees. So we found out that this missing angle PCA equals to 90 degrees. Therefore, the triangle PCA must be a right triangle. Okay, so here, the green triangle PCA must be a right triangle because it has one angle that is equal to 90 degrees. So I copied triangle PCA in a new page and we implemented here the Pythagoras theorem. This is the right triangle PCA, the other green triangle PCA, that I copied from the original drawing. PC equals to A equals to the square root of 6 minus 1 units, AC equals to 2 times square root of 3 units, and line segment or the hypotenuse AB equals to X, that is the line segment that we are looking for. We implemented here the Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AP, therefore the square of the hypotenuse is AP squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PC squared plus AC squared. AP equals to X, therefore AP squared is X squared. PC is square root of 6 minus 1, therefore PC squared is square root of 6 minus 1 squared, plus AC squared. AC is 2 times square root of 3, therefore AC squared is 2 times square root of 3 squared. So X squared equals to square root of 6 minus 1 squared, and 2 times square root of 3 squared equals to 2 squared, that is 4, times square root of 3 squared, that is 3. 4 times 3 is 12. So in conclusion, found out that according to the Pythagoras theorem, X squared equals to the square root of 6 minus 1 squared plus 12. In order to find out the value of the expression square root of 6 minus 1 squared, we implemented here the algebraic identity that states that A minus B squared equals to A squared plus B squared minus 2 times AB. In our specific expression, A equals to the square root of 6 and B equals to 1. And therefore, according to this algebraic identity, we get that square root of 6 minus 1 squared equals to A squared. A is square root of 6 equals to the square root of 6, therefore A squared is square root of 6 squared, that is 6. Plus B squared, B is 1, so B squared is 1 squared, that is 1. So we have 6 plus 1 minus 2 times AB. Minus 2 times A is square root of 6 and B is 1. Therefore, minus 2 times AB is this 2 times square root of 6. In conclusion, found out that the value of this expression minus 6, square root of 6 minus 1 square, it is equal to 6 plus 1 minus 2 times square root of 6. 6 plus 1 is 7, so this expression in total, square root of 6 minus 1 square equals to 7 minus 2 times square root of 6. So we can substitute square root of 6 minus 1 square in this equation by 7 minus 2 times square root of 6. We did it, and we got that x squared equals to square root of 6 minus 1 square is 7 minus 2 times square root of 6, and we have to add here plus 12. Plus 12, so x squared equals to 7 plus 12, that is 19. 19 minus 2 times square root of 6. In conclusion, found out that x squared equals to 19 minus 2 times square root of 6. Here we took out of this equation and we found out that x equals to the square root of 19 minus 2 times square root of 6. Or in terms of numbers, x equals to 3.755 units. I'll repeat again. Line segment AP that is equal to x. It is equal to either the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, AP that is equal to x, it is equal to 3.755 units. Okay, thank you very much.